Okay, so today we're going to do a quick tutorial on the digital multimeter. Now this instrument can allow us to measure different things such as DC voltage, AC voltage, resistance, continuity, and this model can even measure temperature with a thermocouple. So today we're going to be focusing on DC voltage in particular. So if I put this up next to the little camera here. DC voltage is represented up here in the left-hand quadrant. AC voltage is in the top right quadrant. The difference is that DC voltage here you can see it is measured, the symbol uses a line with dashed lines underneath it, where the AC voltage uses a squiggle. So if you notice that there's actually a range in voltages here on our DC voltage. So this one measures down into the millivolt range up into the hundreds of volt range. So you choose the voltage range that you'll be using for your purposes. So in this experiment, we're going to be using just some batteries at around 5 volts. So I'm going to select the 20 volt range. Now if I were going to be measuring higher voltage, I'd go to 600. If I was going to be measuring lower voltage, I'd go down to the millivolt range. Okay, so the multimeter comes with a couple of leads. It has a positive lead and a negative lead. The negative lead gets plugged into the slot labeled COM, and the positive lead gets plugged into, depending on what you're measuring. Well, I can't take it out. Voltage, resistance, or in this case, a very low current. Now, it's important not to plug your lead into the 10 amp there unless you're measuring specifically amps, but we're not for this case, so we don't need to worry about that. So, I'm going to be measuring, with these leads, the voltage across the terminals on a battery. So, with this battery here, I can measure the negative terminal and then the positive terminal, and I get a voltage of about 1.7. If I take another battery here, here's another battery. If I measure the voltage across these ones, I get about 1.78. And then here's another battery. And I measure the voltage across that. I go 1.8. There's some little bit of variation among batteries themselves. Now, if let's say I took the battery and I measured the terminals in reverse, so I've put the negative lead onto the positive terminal of the battery and measured, I get a voltage that's measured in negative. That's fine. That's okay. Just reverse your polarity and then measure it again. Now, it's going to read the same exact thing, but in reverse. Okay, so for this purposes of this lab, I'm going to be measuring my voltages. Well, I'm not going to be using 1.7 volts. I'm going to be closer to 5 volts. So if I take my batteries and I add them up in series, I get a different voltage. Now, here are my batteries in series. Now, if I measure the voltage across the terminals here, I get 3.6 volts. Now, the voltage across one of these batteries is 1.8, probably what it was before. The voltage across the other one is about 1.8, again, what it was before. Across both of them, I get about 3.6. So that's about double, which is, the additive quality of putting batteries in series. Now, let's say if I added one of these batteries in reverse. So I'm going to take this battery, I'm going to flip it around. I'm going to now measure the voltage across these two batteries in reverse. Look, it's close to 0. That's because it's additive, and if I add the same value with a negative polarity, it basically subtracts. So I want these 3 batteries here instead. I'm going to put these 3 batteries in series. Now I got to find the wire here, because I want close to 5 volts across my batteries. So now if I look at the voltage on my batteries, it's about 5 volts. Okay, now I'm going to connect my batteries to my breadboard. So now I've built this breadboard here with these 2 wires across the side. These wires are called rails. So I'm going to connect these rails. Sorry, a little bit of a tangle. Connecting the batteries to my rails. this one over here. Now I'm going to measure the voltage across my rails. Okay, so now the voltage across my rails should read about voltage across my batteries, okay? So the voltage across my rails is about 5.4. The voltage across all of my batteries is 5.4. Across one of the batteries, 1.8. The other battery, 1.8. And the other battery, 1.7. Add it all together, I should get about 5.4. Now, let's build our circuit. First thing we'll put in our circuit is this resistor. Also, it's a light bulb. So, I'm going to put this resistor into our circuit like this, in series with our battery. And it lights up. It's a light bulb. So, now if I look at the resistance across my rails, it has dropped a little bit, so when batteries are outputting current, the voltage changes a little bit. That's okay. That's okay. So the rails read 4 volts. Now the voltage drop across our light bulb is about 4 volts. Now, it doesn't read exactly 4 volts because whenever you have a connection between, let's say, this alligator clip and this wire, or this alligator clip and this clip itself here, the little bit of resistance between that connection can cause a voltage drop between there. So it's not going to be exact all the time. But it's close. Look at that. It's about 4 volts in each case. Okay, now, next we're going to add another light bulb in series to this one. So I'm going to get another light bulb here. Make note of the brightness of this light bulb here, because I'm going to ask you what the brightness of the next one will be. So, here are my light bulbs. I'm going to connect them in series with each other. Look, notice how the brightness is significantly reduced. Now, remember the voltage drop across the batteries last time was about 4 volts. So now I'm going to measure the voltage drop across each of these now after hooking up in series. Well, the voltage drop across the rails, about the same. It's about 4 volts. Voltage drop across both of these batteries, these light bulbs, it's the same. It's about 4 volts. Now, each individually, look, it's about 2 volts. Notice it has halved. Okay? Make note of that again, because I'm going to add another light bulb. Guess what? In series. So I'm going to take my other light bulb. Here is my third light bulb. Notice how it's even dimmer. Maybe you can't even see it. So I'm going to take my leads and measure the voltage drop across the system. Whoops. I lost a battery. 1 second. There we go. Okay. Let's try it again. Measure the voltage drop across the system. That's about 4 volts, where it was before. Voltage drop across all of the batteries. Same thing, about 4 volts. Now, if I measure the voltage drop across each battery individually, look, it's about 1.3. This one, well, 1.4. And this one, 1.3. Notice how it's in thirds. Okay. Now, what happens if we connect our light bulbs in parallel? So I'm going to unhook all these things. Okay, so we're just going to plug this one back into its battery configuration there. Notice the brightness on that light bulb. And as a reminder, voltage drop across this light bulb is 4 volts. Now I'm going to add another light bulb in there in parallel. Okay. Here's our second light bulb. Watch. Notice how the brightness of this light bulb did not change when we connected this light bulb. Now let's look at the voltage drop. The voltage across the rails, a little bit lower, but about 3.5 volts maybe. Voltage drop across this one. This light bulb is about 3.3 volts. Voltage drop across this one, about 3.3 volts. Now, it's not exactly 4 volts like it was before, but that's a little bit more complicated to explain. Now, if I add another light bulb in parallel to these light bulbs, watch this. Now, make note of the brightness of these light bulbs here. Okay, the brightness did change a tad bit, but not very significantly. Now, let's look at the voltage drop across the system on the rails. It's about 2.7 volts. Now, it's not exactly 4 volts like it was before, but that's okay. That's about how much current the batteries are able to produce, which you'll discuss later. Voltage drop across this one should be the same, and then the voltage drop across this one also about the same. So let's say we take the system and make it a little bit more complicated now. Okay, so I'm going to leave one of these here connected. I'm going to disconnect the other ones. All these wires. Okay. Okay. All right. So I have this one connected. Now I'm going to add the other two light bulbs in series together in parallel with this light bulb. Okay. Almost done. All right, now make note of the brightness of the light bulbs. This one changed a little bit, but not significantly. And then these two light bulbs lit up. Notice how these light bulbs here are maybe about half the brightness of this one right here. So let's look at the voltage drop across the system again. About 3.5 volts. The voltage drop across the single light bulb should be about 3.5 volts. The voltage drop across the pair in series, the pair itself is about 3.5 volts, but each individual one, half that. Okay. All right, so this concludes our tutorial on how to use the voltmeter to measure voltage, or the multimeter to measure voltage, and applying it to measuring the voltage drops across lights in series and in parallel.